In the vast expanse of our solar system, far beyond the familiar planets, lies a realm of icy bodies and enigmatic moons. Among them is Caliban, a small, irregular moon orbiting the ice giant Uranus. Caliban is a member of Uranus's outer moons, a group of satellites that stand apart from the planet's inner moons due to their unusual orbits and origins. These celestial bodies hold clues to the early solar system and the processes that shape the planetary systems we observe today. Caliban's story is one of cosmic collisions, gravitational capture, and the enduring power of gravity. Its discovery in 1997 opened a new window into the complex history of our solar system, revealing the dynamic interactions that have shaped the planetary systems we observe today. By studying Caliban, astronomers hope to gain a deeper understanding of the processes that govern the formation and evolution of planetary systems, both within our solar system and beyond, i.e., Caliban's discovery was a testament to the power of modern astronomy and the dedication of the scientists who tirelessly explore our solar system. In 1997, a team of astronomers led by Brett Gladman and Philip Nicholson pointed their telescopes towards Uranus, hoping to uncover new secrets hidden within the planet's faint ring system. Using the world-renowned Hale Telescope at Palomar Observatory in California, they embarked on a mission to observe Uranus with unprecedented detail. As they analyzed the data, a faint, previously undetected object emerged from the background stars. It was a small, dim moon, moving slowly across the sky in a distant orbit around Uranus. The discovery of Caliban sent ripples of excitement through the astronomical community, as it added a new piece to the puzzle of Uranus's complex system of moons and rings. The newly found moon was initially designated as S1997U1, a temporary name assigned to newly discovered satellites. Unlike Uranus's inner moons, which are thought to have formed from the same disk of gas and dust that birthed the planet, Caliban's origins lie much farther out in the solar system. Astronomers believe that Caliban is a captured object, most likely originating from the Kuiper Belt, a region beyond Neptune populated by icy remnants from the early solar system. The Kuiper Belt is a vast reservoir of icy bodies, remnants from the early solar system, and the source of many short-period comets. Billions of years ago, during a period of intense gravitational upheaval in the early solar system, Caliban's path would have intersected with that of Uranus. Gravitational interactions with the giant planet, perhaps assisted by collisions with other objects, would have slowed Caliban down, capturing it into its current distant and irregular orbit. This cosmic dance of attraction and capture is a common theme in the evolution of planetary systems, and Caliban stands as a testament to the dynamic nature of our solar system's history. From our vantage point on Earth, Caliban appears as a faint point of light, even through the most powerful telescopes. However, astronomers have been able to piece together a basic understanding of its physical characteristics. Based on its brightness and estimated reflectivity, Caliban is thought to be a small, icy body, measuring approximately 72 kilometers in diameter. Its surface is likely a mixture of water ice, rock, and perhaps other frozen volatiles, similar in composition to many objects found in the outer solar system. Caliban's surface is also thought to be heavily cratered, bearing the scars of billions of years of impacts from smaller objects. The lack of an atmosphere means that there is no wind or weather to erode these impact craters, leaving them as a permanent record of the moon's violent past. The combination of ice, rock, and impact craters creates a stark and ancient landscape, forever shrouded in the dim light of the distant sun. Section 5. Dancing against the tide, Caliban's retrograde orbit. One of the most intriguing aspects of Caliban is its unusual orbit. Unlike most of the moons in our solar system, which orbit their planets in the same direction as the planet's rotation, Caliban's orbit is retrograde. This means that it orbits Uranus in the opposite direction to the planet's spin. Caliban's retrograde orbit is a strong indicator of its captured origin, as objects formed in the same disk as their parent planet are unlikely to have such orbits. Caliban's orbit is also highly elliptical, meaning that its distance from Uranus varies significantly throughout its orbital period. At its closest approach, Caliban comes within 7.2 million kilometers of Uranus, while at its farthest point, it swings out to over 12 million kilometers away. This eccentric orbit, combined with its retrograde motion, makes Caliban a fascinating object for astronomers studying the dynamics of planetary systems. Section 6. Gravitational capture, a celestial dance of attraction. Caliban's capture into its current orbit around Uranus is a testament to the subtle but powerful force of gravity. Billions of years ago, when the solar system was a much more chaotic place, Caliban likely originated in the Kuiper Belt, a region beyond Neptune populated by icy remnants from the early solar system. Gravitational interactions with the giant planets, particularly Neptune, could have perturbed Caliban's orbit, sending it on a trajectory that crossed paths with Uranus. As Caliban approached Uranus, the giant planet's gravity would have exerted a pull on the smaller body. This gravitational tug would have slowed Caliban down, causing it to lose energy and gradually spiral inward. Over time, Caliban's orbit would have circularized, settling into its current distant and retrograde path. This process of gravitational capture is thought to be a common mechanism for the formation of irregular satellite systems around giant planets. Section 7. Unlocking the secrets of our solar system. Caliban's significance. While Caliban may seem like a small and insignificant object in the grand scheme of the cosmos, its study holds significant scientific value. As a captured object from the distant Kuiper Belt, Caliban provides a unique window into the composition and dynamics of the early solar system. By studying its surface composition, astronomers can gain insights into the building blocks that were present during the solar system's formation. Furthermore, Caliban's unusual orbit provides valuable clues about the history of gravitational interactions in the Uranian system. The capture of Caliban and other irregular moons suggests that Uranus experienced a period of significant dynamical evolution after its formation. By modeling these interactions, astronomers can refine their understanding of how giant planets acquire and shape their satellite systems. Section 8. Future Exploration, Unraveling Caliban's Mysteries. Despite its scientific significance, Caliban remains a poorly understood object. Its small size and extreme distance from Earth make it a challenging target for observation, even with the most powerful telescopes. However, future missions to the outer solar system could provide an opportunity to study Caliban in greater detail. A dedicated mission to Uranus could include a flyby of Caliban, allowing scientists to obtain high-resolution images of its surface and potentially even map its composition. Such a mission could also study Caliban's gravitational field, providing insights into its internal structure and density. The data gathered from such a mission would be invaluable for unraveling the mysteries of Caliban and other irregular moons in the outer solar system. Section 9. Caliban in context, comparing Uranus's irregular moons. Caliban is just one of many irregular moons that orbit Uranus. These moons, characterized by their distant, eccentric, and often retrograde orbits, are thought to be captured objects from the Kuiper Belt or even farther out in the solar system. Comparing and contrasting the properties of these moons can provide valuable insights into the processes that shaped the Uranian system. For example, by comparing the orbital characteristics of Caliban with those of other irregular moons, such as Sycorax and Prospero, astronomers can learn about the different capture mechanisms that may have been at play. Similarly, studying the size and color distributions of these moons can provide clues about the composition of the Kuiper Belt and the conditions that existed in the early solar system. Section 10. Conclusion. Caliban, a window into the solar system's past. In the grand tapestry of the cosmos, Caliban may seem like a small and insignificant object. However, this distant icy moon holds valuable clues to the history of our solar system. Its capture from the Kuiper Belt, its unusual orbit, and its icy composition all speak to the dynamic processes that have shaped the planetary systems we observe today. By studying Caliban and other irregular moons, astronomers are piecing together the story of our solar system's formation and evolution. These celestial time capsules provide a glimpse into a distant past, when the planets were young and the solar system was a much more chaotic place. As we continue to explore the cosmos, objects like Caliban will undoubtedly reveal even more secrets about our place in the universe.